Hey guys, this is Science for 7th and 8th, and this is Science for Faith. I tried to turn this a little bit to where maybe it wouldn't be so reflective into my glasses, but oh well, it's not working out really well. So we have a short lesson today on tree structure. We're still on chapter 12. We're starting on page 437. We're going over to page 439, so 437 to 439. And we're basically starting a section of a chapter, continuing in chapter 12, which is forestry, and we're starting today's section is on tree structure, mainly going over roots. But before we go into our lesson, let's take a brief word of thanksgiving to the Lord in prayer. Heavenly Father, we just want to thank you and praise you that, like the roots of a tree, we are rooted in you, and we need to stay rooted in you. And Father, thank you for granting us salvation through your Son, Jesus Christ. Thank you for giving us the opportunity to still reach and learn and talk to each other during a pandemic. I mean, that wouldn't have happened like 100 years ago. And Father, just be with us, grant us the wisdom of heaven, grant the authority figures over us the wisdom of heaven, and we love you in Jesus' name, amen. All right, guys, so page 437, we're on tree structure, and we're starting from way down in the ground on up. I recently had, I guess because our ground is so saturated, I have some trees that fell over into my yard. This has happened here the past 2 years. I think we're getting some trees that are just really, really saturated and in their root system and they just fall over. So if you've got the opportunity to look at a tree that's fallen over and you can really see its roots really well, that's something interesting, because most of the time when a tree falls over, it's not just like, you have this big gaping hole where all these roots tore up, because that's how much support that tree needed. So trees grow and function like green plants, but the basic parts of a woody tree are the same as that of a herbaceous plant like we studied in chapter 2. They have roots, they have stems, they have leaves, but their roots are super important. Although seldom seen, roots are an important part of the tree. Like roots of herbaceous plants, tree roots occur at either tap roots, or as spreading root. And I know that when you look at a tree, let's just say you're underneath a maple tree, underneath an oak tree. One way you can imagine how much the structure of those roots are underground is look up at the crown of the tree, of whatever tree you're under, and then go to where the end of that crown is. So let's say it's noon. It's a sunny day. You're underneath this big oak, this big elm, this big maple. Go to where there's no shade. That's the end of the crown of the tree, because most of the time at noon, the sun's shining straight down. That is where the roots end. The roots are actually extending beyond the crown of the tree. That's how far the tree's roots are extending. And I know that people who are into dendrology and forestry, if you're going to fertilize your trees, that's where you fertilize. You think you go to the trunk of the tree and go, there's my fertilize. But that's not it. You go to where the end of those reaching roots are. Just like pretty soon we're going to be growing corn and doing stuff like that, and you don't dump fertilize at the stem of your corn. You dump it further out, because corn roots have these really spreading roots too. So tap roots are like that dandelion. I'm going to have to dig one of those up. Their tap roots are large main roots that go deep into the ground and frequently have secondary horizontal roots branching off that big main tap root. And they're often found on trees that grow in dry areas, mainly because they go through periods of extended droughts. Next year, you're going to study earth sciences, 7th graders. 8th graders have already had it. Underneath our earth, we have what's called aquifers. And before you think, what's an aquifer? It's basically what you're hitting when you're digging a well. You're getting that. So we have an underground water system. When you get into a cave, you can see that really well, because most caves have a creek that's running through it or some water is running through it. so that the tap roots enables those trees to reach that groundwater deep, deep within the earth. So examples of trees with a tap root would be like a black oak or a ponderosa pine, that pine that really spreads out. Spreading roots are similar to fibrous roots. They're found on herbaceous plants, but the primary difference is the root's diameter. So a spreading root system consists of several equally sized roots that spread out within the first 3 to 7 feet of the surface soil. There's no one dominant root. A tree's root system may extend 3 times farther outside its crown. So see, like, for example, you've got American elm. That tells us 3 times further out from its crown is that tree's roots. Trees with spreading roots, which include the Engelmann spruce and the American elm, usually grow in areas that receive a lot of rain, which is where you live. You live in the temperate region of the United States, and we get a lot of rain. So I said, man, if Abraham saw this place, if Noah saw this place, he would be like, where am I? They probably can think it's almost heaven to them. So the roots of a tree perform 3 important functions, just like they do for the plant that we study. They absorb water and minerals, they anchor that tree firmly into the soil, and they store food. And of course, here recently, because of all the rain we've been having over really the past year or so, some of these, the soil is getting so saturated that the weight of that tree is just falling over. That happened to a large cedar, happened to a walnut last year in my yard. This past, when was it? Sunday night? Whatever night we had a lot of rain. We had a cedar that was starting to lean, and as it was going down, it took down another tree into our yard too. So it's like, yay, right? So the roots, if we look at the absorbing ability of a root is amazing. A single birch tree may have as many as 200,000 leaves, which on a hot summer day may transpire 900 gallons of water. Every drop of that water has to be absorbed from those roots that's down in the soil. And for a tree, roots are about 15% of that tree's overall weight. So once again, you can see where if the soil is really saturated and the roots are going back and forth and there's a little bit of wind, that tree's just going to go on over. As the roots probe through the soil, they also anchor the tree by packing the soil grains tightly against each other. Roots maintain this pressure by growing thicker, and in this way, a top-heavy forest giant can stand tall against ordinary winds. Many are so firmly anchored that even hurricane-force winds can't move them. And that's why I said sometimes when trees fall most of the time, it's not just wind. It's a combination of saturation of soil combined with that wind. That's normally what happens. A taproot's primary purpose is to store food, while a spreading root system's primary purpose is to anchor that plant down. Some species of a tree can develop either system depending on their habitat. Most trees have a taproot as a sapling, that's a young tree, a baby tree, but change to a spreading root system as they age. The initial taproot will store any extra food that tree requires for it's just shooting up during that extra root, it requires that extra food as it's growing. Or it might to survive a period of dormancy, to survive a period of drought. But most trees that maintain their taproot system into adulthood are nut or citrus trees. So nut or citrus trees, you can just imagine they're trying to produce this fruit, so they might require that greater taproot system in order to store more food and more nourishment for that tree. Now, if you want to look at really weird roots, because we talked about 2 traditional roots, taproot system, spreading root system. Weird roots are on page 438 and 439, and that's where we're ending our lesson. So, and they call it souped up roots, right? Souped up roots. Well, God provided certain tree species with specialized roots to help them survive in their environment. So we have adventitious roots, or roots that grow from a plant stem, branches, leaves, or mature woody roots. These roots usually work differently than a normal root, and they perform a different task. Those roots, they don't just bring up nourishment bring up water, they actually do a gas exchange, very similar to what a tree, a stem would do, or those roots are there for one purpose only, and that's for tree support. A single tree might have several types of adventitious roots all at one time. So there's aerial roots that are found partly or entirely above the ground, and you can see there with the cypress, there's some aerial roots that are coming up. These roots are often used to stabilize and to support the tree. One type of aerial root is a buttress root, which are common in large tropical trees and occur at the base. Buttress roots look like a large wall or a buttress. It's not an insult, that's, like a fort. So they're like large walls or plank-like extensions that provide additional support to that stem, and it prevents that tree from tumbling. Because you can notice these trees are like in swamps and they're in tropical areas, which means their soil is super, super saturated. And that's the only way these trees would actually exist and continue standing in these conditions. They tend to occur more often on the side of a tree that faces the wind, obviously, to support it. Frequently, buttress roots can be found in wet, lowland environments, stabilizing the tree as it rests in a swampy, shifting ground. Bald cypress is known for both its buttress roots as well as its knees, which is another type of aerial root. And it tells me in mind what the function of, if any, of a cypress knee is. Dendrologists don't know. They have two theories. They think that maybe the knee, that little root that just sticks up, is providing air for roots in underwater soil, and they provide some type of structural support. Some scientists, though, think they're just there. They serve no purpose. It's just a knee. So whatever. To me, it looks like something that you could trip over and impale yourself on as you're trying to go through the swamp. So just don't go through the swamp at night. So it's a different type of aerial root that actually grows out of the ground some distance from the plant. So then we have prop roots, also known as stilt roots. You've got a picture of a walking palm there. Walking palms are named based on disputed claims that they can actually use their prop roots to slowly walk around the forest, moving up to several meters a year to find better lighting conditions. There's no evidence that this happens, okay? But I guess in the old days when they were naming this thing is walking around, knowing that the tree might shift this way and that way. It's not going to walk like several meters, though. That's like weird. So prop roots grow out from the side of a stem, looking somewhat like a downward growing branch or trunk. Some tall, slender trees have prop roots that grow near the bottom to provide extra support. An Asian banyan tree that you have there on page 438 from the ficus or fig genus grows many prop roots from its large branches to support a really wide canopy. And you can kind of see that this banyan tree its canopy is really wide. Some banyan trees can have a canopy that covers more than 5 acres, if you can imagine. So you need a lot of props for that, and that's what those roots are for. Then you have strangler figs, which is another type of aerial root that's there on page 439. And if you think of a strangler fig, it's doing the same thing like a strangler would do to you. This strangler root is doing that to another tree. So several species in the same genus as the banyans use aerial roots to basically live as a parasite on another tree. The strangler fig seed is dropped to the top of another tree by some animal. And as that fig grows, it will send aerial roots downward, and it basically encompasses this tree around like a snake, a boa constrictor. That host tree dies because it's slowly engulfed and strangled by the strangler fig's roots. The fig's roots then become a new trunk. Botanists use the ability of trees to grow roots from places other than the base of the trunk in order to cultivate a new tree. We talked about this in chapter 2. If you don't use a seed, if you use a root, or a branch or something like that. That's called vegetative propagation. We learned about that in chapter 2. That allows a botanist to produce a new tree from a root, from a stem, or a leaf rather than a seed. If you have a weeping willow tree, or if you know of one, first of all, those trees, you don't want to plant them anywhere where there's a sewage system or you've got pipes or there's any type of fill lines that's coming from your what's it called? Your sewage tank, whatever it's called. It's not called that. But because a weeping willow has really aggressive roots and it's been known to destroy piping and plants, and things like that. But if you have a safe place to put a willow, they do like water, you can pick one of those whips from the weeping willow and just take some leaves off the bottom, and it's easy to do some vegetative propagation. Just take one of those whips, stick her in the ground, and that will grow. And a weeping willow is a fairly fast growing tree comparatively to some trees that we have. So one method of propagation is cutting, and in this technique a piece of a stem or a root is placed in water or moist soil to encourage new root growth from the cut end. Once the roots have sprouted, then the newly tree will be planted. Many healthy trees can be grown in this manner, so that makes a way where you don't have to start with a seed. You're already starting with this big stem, like the weeping willow. You're not starting like with this. You're starting with this big stem that's already starting to grow. Lots of people will do things, botanists, dendrologists, whatever they are. That's how they're able to produce trees, or if you're in a nursery, to do that. I will say that if you're at a nursery, if you're a forestry person, what they typically do is they put some rooting hormone on the bottom of these cuttings, and that helps that tree. It's just like a fertilizer, if you can imagine, but it's not. It's more of a hormone that encourages that cutting to really grow. So that's where we're stopping. Tomorrow, if I can remember, I'm going to try to find a branch to bring it in, because it kind of gets, or maybe a piece of bark. I'll see if my husband's got something like that laying around, and we can even get maybe a young woody stem. If I can't get one, you go out right now and try to find you one, and then you can kind of be looking at it as we talk about what this looks like. So today's lesson is for Today's lesson was actually for May 1st. So it's Science 7th and 8th for May 1st. I'll see you again on 2nd, 3rd. We'll have another lesson on May 4th. So maybe over the weekend you can try to find that branch, and you can kind of look at this branch while we're getting ready to do this lesson. So have a great rest of the day. Hopefully it's sunny where you're at and you can get out and play. So see you later.